ওয়েলকাম ফ্রেন্ডস, ওয়েলকাম টু মাই চ্যানেল। তো আজকে তোমাদের ফ্লুইড মেকানিক্সের কোশ্চেনগুলো আলোচনা করব খুরমি গুপ্তা বই থেকে। কোশ্চেন নম্বর 1 টু কোশ্চেন নম্বর 100। তো চলো শুরু করা যাক। লেটস স্টার্ট। Question number 1. The mass per unit volume of a liquid at a standard temperature and pressure is called mass density. Option B is right answer. The formula for mass density equal to mass of a liquid divided by volume of a liquid. And mass density is denoted by rho. Rho is equal to mass by volume, m by v. So option B is right answer. Question number 2. The volume per unit mass of a liquid is called specific volume. Right. Option A is right answer. Specific volume is 1 by mass density. Question number 3. The weight per unit volume of a liquid at a standard temperature and pressure is called weight density or specific weight. Option A is right answer. So specific weight or weight density equal to weight of a liquid divided by volume of a liquid. Question number 4. Specific weight of water in SI unit is taken as 9.81 kN per meter cube. Option A is right answer. Question number 5. The ratio of specific weight of a liquid to the specific weight of pure water at standard temperature is called specific gravity of liquid. Option B is right answer. Question number 6. The specific gravity has no units. Right. Option A is right answer. Agree. Because it is the ratio of specific weight of a liquid to the specific weight of pure water. So specific weight and specific weight will be crossed. That's why it has no units. Question number 7. The specific weight of seawater is more than that of pure water. Option C is right answer. The specific weight of seawater is more than that of pure water because in case of seawater, dissolved salts, minerals involved with seawater. That's why the specific weight of seawater is more than that of pure water. Question number 9. The density of a liquid in kg per m3 is numerically equal to its specific gravity. Option A is right answer. True. Question number 10. The specific weight is also known as weight density. Right. Option A is right answer. Correct. Question number 11. The mass of 2.5 m3 of a certain liquid is 2 tons. Its mass density is. So we know the formula of mass density, rho equal to m by v. M is the weight of the liquid and v is the volume of the liquid. So the weight is given here 2 tons. That means 2 into 10 to the power 3 kg divided by volume 2.5 m cube. So if we calculate the value will be mass density equal to 800 kg per m cube. Option D is right answer. Question number 12. The specific gravity of an oil whose specific weight is 7.85 kN per meter cube is. We know the formula of specific gravity of a liquid equal to specific weight of a liquid divided by specific weight of pure water at 4 degrees Celsius or standard temperature. So specific gravity of that oil will be equal to specific weight of that oil divided by specific weight of pure water. So that means 7.85 divided by 9.81. That means if we calculate the value will be 0.8. Option A is right answer. Question number 13. A vessel of 4 m3 contains an oil which weighs 30 kN. The specific weight of the oil is. We know the formula for specific weight or weight density equal to weight of a liquid divided by volume of a liquid. So here the given weight of the liquid is 30 kN and the volume of the liquid is 4 m3. So if we calculate the specific weight will be equal to 30 divided by 4. That means 7.5 kN per meter cube. Option C is right answer. Question number 14. The property of a liquid which offers resistance to the movement of one layer of liquid over another adjacent layer of liquid is called viscosity. Option D is right answer. The internal resistance between the fluid layer is known as viscosity. So option D is right answer. Question number 15. The kinematic viscosity is product of dynamic viscosity and density of the liquid. No. Dynamic viscosity is the product of kinematic viscosity and density of the liquid. So option B is the right answer. Question number 16. The force per unit length is unit of surface tension. Option A is right answer. And the surface tension is a tendency of a liquid surfaces at rest to shrink into minimum possible surface area displayed by its acting as if it were a stretched elastic membrane. Compressibility. The change in volume of a liquid due to unit variation of pressure is called compressibility of the liquid. And capillarity. The phenomenon in which liquid spontaneously rises or falls in a thin tubes or in the voids of a porous material is known as capillarity of liquid. Question number 17. The variation in the volume of a liquid with the variation of pressure is called its compressibility. Option B is right answer. Question number 18. The property of a liquid which enables it to resist tensile stress is called its surface tension. Option A is right answer. Agree. Question number 19. When a tube of smaller diameter is dipped in water, the water rises in the tube due to viscosity of water. No, due to capillarity of water. So option B is right answer. False. Question number 20. When a tube of smaller diameter is dipped in water, the water rises in the tube with an upward concave surface. And in case of mercury, in the tube with an upward convex surface. So option A is right answer for this question. The rise of liquid in case of water will be upward concave, and in case of mercury it will be upward convex. Question number 21. A glass tube of smaller diameter is used while performing an experiment for capillary rise of water because it is easier to see through the glass tube. Option A is right answer. Question number 22. The mercury does not weight the glass. This is due to the property of liquid is known as cohesion. Option A is right answer. Because the cohesive force between the molecules of the mercury is more than the adhesion between the glass and mercury. So that's why mercury does not weight the glass. Option A is right answer. Cohesion is the attraction between the molecules of the same substance, and adhesion is the attraction between the molecules of two different substances. Okay. Question number 23. With an increase in size of tube, the rise or depression of liquid in the tube due to surface tension will always decrease. Option A is right answer. We know the capillary rise or depression is inversely proportional to the size of the capillary tube. So if we increase the size of the tube, the rise or depression of the liquid in the tube will decrease. Option A is right answer. And the formula for capillary rise H will be equal to 4 sigma cos alpha divided by WD. Alpha is the angle of contact of the liquid surface, sigma is the surface tension, W is the specific weight of the liquid, and R is the radius of the tube. This is angle of contrast of theta. It will be alpha. I have written theta. Question number 24. A glass tube of small diameter D is dipped in fluid. The height of rise or fall into the tube is given by. Option C is right answer. 4 sigma cos alpha divided by WD, where W is the specific weight of the liquid, alpha is the angle of contact of the liquid surface, and sigma is the surface tension. Question number 25. In the manufacturing of lead sorts, the property of surface tension is utilized. Right. Option A is right answer, and that is the reason behind while descending spherical shape is obtained. Question number 26. The surface tension of mercury at normal temperature is higher than that of water. Option C is right answer. Question number 27. The unit of surface tension is force per unit length is the unit of surface tension. So option A is right answer. Question number 28. The viscosity of a liquid is due to the cohesion of its particles. Right. Option A is right answer. Correct. Question number 29. The viscosity of a liquid affects its rate of flow through a hole in a vessel. Option A is right answer. Question number 30. The viscosity of water is lower than that of mercury. Option B is right answer. Question number 31. Falling drops of water becomes fierce due to the property of surface tension of water. Option A is right answer. Question number 32. The intensity of pressure at any point in a liquid is directly proportional to the depth of the liquid from the surface. Option B is right answer, because the formula for intensity of pressure P will be equal to W into H. W is the specific weight of the liquid and h is the depth of the liquid from the surface. So intensity of pressure is directly proportional to the depth of the liquid from the surface. Question number 33. The pressure intensity in kilonewton per meter square or kPa at any point in a liquid is W into H. Option B is right answer. W is the specific weight of the liquid and H is the depth of the liquid from the surface. Question number 34. The pressure at a point 4 meter below the free surface of water is, so intensity of pressure P will be equal to W into H. W is the specific weight of the water, which is equal to 9.81 kilonewton per meter cube, and H is the depth of the liquid from the surface, and H is the depth of the liquid given here 4 meter below the surface of water. So intensity of pressure P will be equal to 9.81 into 4, that means 39.24 kPa. Option C is right answer. Question number 35. The height of a water column equivalent to pressure of 0.15 MPa is. We know the formula of pressure P equal to W into H, or intensity of pressure P equal to W into H. So intensity of pressure is given here 0.15 MPa, that means 0.15 into 10 to the power 6 Newton per meter square, and W is the specific weight of water, which is equal to 9.81 kilonewton per meter cube, or 9.81 into 10 to the power 3 kilonewton per meter cube into the height of water column. So if we calculate, the volume value will be equal to 15.3 meter. Option A is right answer. The head H will be equal to the intensity of pressure 0.15 into 10 to the power 6 Newton per meter square divided by the specific weight of the liquid, that is water. So 9.81 into 10 to the power 3 Newton per meter cube. The head will be equal to 15.3 meter. Question number 36. The intensity of pressure at any point in a liquid is directly proportional to the depth of the liquid from the surface. Option B is right answer, because we know the formula of intensity of pressure P is equal to W into H. W is the specific weight of the liquid and H is the depth of the liquid from the surface. Question number 37. According to Pascal's law, the intensity of pressure at any point in a fluid at rest is the same in all directions. Option A is right answer. Agree. Question number 38. Water is an incompressible liquid. Option B is right answer. Question number 39. The pressure measured with the help of a pressure gauge is called gauge pressure. Option B is right answer. Look at this. This is the atmospheric pressure. This is the absolute zero pressure. Then this is atmospheric pressure, and above this is the gauge pressure, and below this is the vacuum pressure. So from this picture we can write P absolute, or absolute pressure, equal to P atmosphere atmospheric pressure plus gauge pressure P gauge, and vacuum pressure P vac equal to atmospheric pressure P atom minus P absolute pressure. Question number 40. The atmospheric pressure at sea level is. Option A 103 kN per meter square. Option B 10.3 meter of water. Option C 760 mm of mercury. Option D is right answer, all of these. Question number 41. The density of air is same at different heights. No, the density of air goes on decreasing as the height increases. Option B is right answer. Question number 42. When the pressure intensity at a point is more than local atmospheric pressure, then the difference of these two pressure is called gauge pressure. Option A is right answer. Question number 43. When the pressure intensity at a point is less than the local atmospheric pressure, then the difference of these two pressure is called vacuum pressure. Option A is right answer. Agree. Question number 44. The vacuum pressure is always the negative gauge pressure. Option A is right answer. Question number 45. The absolute pressure is equal to gauge pressure plus atmospheric pressure. Option A is right answer. Question number 46. The pressure less than the atmospheric pressure is known as suction pressure, vacuum pressure, negative gauge pressure. Option D is right answer, all of these. Question number 47. The gauge pressure at a point is equal to the absolute pressure minus the atmospheric pressure. Option B is right answer. Question number 48. The pressure of a liquid measured with the help of a piezometer tube is gauge pressure. Option B is right answer. Question number 49. The vacuum pressure can be measured with the help of a piezometer tube. No. Option B is right answer. This can be measured by manometer. Question number 50. The pressure measured with the help of a piezometer tube is in head of the liquid. Option C is right answer. Question number 51. A piezometer tube is used only for measuring moderate pressure. Option C is right answer. Question number 52. The liquid used in the manometer should have high density. Option B is right answer. So that the height of the column can be reduced, because the manometer is used for measuring high pressure measurement. So it is important to make the column height in a practical limit. Question number 53. A manometer is used to measure pressure in pipes and channels. Option B is right answer. Question number 54. A manometer is used to measure high pressure. Option C is right answer. Question number 55. A manometer can be used to measure vacuum pressures. Option A is right answer. Agree. Question number 56. A differential manometer is used to measure difference of pressures between 2 points in a pipe. Option D is right answer. Question number 57. The intensity of pressure on an immersed surface increases with the increase in depth. Option B is right answer, because we know the formula of intensity of pressure on an immersed surface equal to W into A into X bar, where W is the specific weight of the liquid, A is the area of the immersed surface, and X bar is the distance between the CG of the immersed body and the liquid surface. From this equation we can say the intensity of pressure P will be is directly proportional to the depth of the liquid surface. So intensity of pressure on an immersed surface increases with the increase in depth. Option B is right answer. Question number 58. The total pressure on a horizontally immersed surface is W into A into X bar. Option C is right answer. W is the specific weight of the liquid, A is the area of the immersed surface, and X bar is the depth of CG of the immersed surface from the liquid surface. Question number 59. The total pressure on an immersed surface inclined at an angle theta with the liquid surface is. Option C is right answer. W into A into X bar. Option C is right answer. Question number 60. The point at which the resultant pressure on an immersed surface acts is known as center of pressure. Option C is right answer. Question number 61. The center of pressure acts below the center of gravity of the immersed surface. Option C is right answer. Question number 62. The depth of center of pressure H bar for a vertically immersed surface from the liquid surface is given by. Option D is right answer. See, this is the vertically immersed surface. So total pressure on this will be W into A into X bar, where W is the specific weight of the liquid, A is the area of the immersed surface, and X bar is the distance between the CG of this body and the liquid surface. And the center of pressure, that is below this total pressure of the on the body, so that will be equal to Ig divided by A into X bar plus X bar, where A is the area of immersed surface, X bar is the depth of CG of the immersed surface from the liquid surface, and Ig is the moment of inertia of the immersed surface about horizontal axis through its CG. Sir, question number 63. The center of pressure for a vertically immersed surface lies at a distance equal to Ig by A X bar below the center of gravity. Option A is right answer. Question number 64. A vertically immersed surface is shown in the figure 3.8. The distance of its center of pressure from the water surface is. For this body, the center of pressure from the water surface H bar will be equal to Ig divided by A into X bar plus X bar. So Ig value will be BDQ by 12. So if we put the value into the equation, we will get the distance of center of pressure from the liquid surface H bar will be equal to d square by 12 into X bar plus X bar. Option B is right answer. Question number 65. The depth of center of pressure for an immersed surface inclined at an angle theta with the liquid surface lies at a distance equal to Ig sin square theta divided by A X bar below the center of gravity. Option A is right answer. The bodies inclined at an angle theta with the liquid surface. So the center of pressure on this immersed body will be H bar equal to Ig sin square theta divided by A into X bar plus X bar. Question number 66. A vertical wall is subjected to a pressure due to one kind of liquid. Due to one on one of its sides, the total pressure on the wall per unit length is. Suppose this is the wall and this is the liquid pressure diagram. So the liquid pressure diagram will be triangular in shape, while it will be 0 at the free surface and maximum at the base level, that is equal to W into H, intensity of pressure. So total pressure will be equal to area of the pressure diagram. So area will be half into base into this height. So WH half into W into H into H. This is the height. So WH square by 2. Total pressure will be WH square by 2. So option C is right answer, WH square by 2, where W is the specific weight of the liquid and H is the height of the liquid. Question number 67. A water tank contains 1.3 meter deep water. The pressure exerted by the water per meter length of the tank is WH square by 2. So W is the specific weight of the water, equal to 9.81 kilonewton per meter cube, and H is the height of the liquid. So if we put the value into the equation, WH square by 2, we will get the value of pressure equal to 8.2829 kilonewton. Option B is the right answer. Question number 68. A vertical wall is subjected to a pressure due to one kind of liquid on one of its sides. The total pressure on the wall acts at a distance 2h by 3 from the liquid surface and h by 3 from the bottom surface. Option C is right answer. H by 3 from this base and 2h by 3 from this top surface, free surface. Question number 69. A vertical wall is subjected to a pressure due to one kind of liquid on one of its sides. Which of the following statement is correct? Option C is right answer. The pressure on the wall at the liquid level is 0 and on the bottom of the wall is maximum. Option C is right answer. Question number 70. When a vertical wall is subjected to pressure due to liquid on both sides, the resultant pressure is the difference of the two pressures. Option B is right answer. Question number 71. In a log gate, the reaction between two gates is P by 2 sine alpha. Option C is right answer, where P is the resultant pressure on the log gate and alpha is the inclination of the gate with normal to the side of the log. BC is the log gate and alpha is the inclination. This angle is the inclination. So the reaction will be P by 2 sine alpha. Question number 72. The water pressure per meter length on a vertically masonry wall of the dam is WH square by 2. Option C is right answer, where W is the specific weight of the liquid and H is the height of the liquid. Question number 73. Match the correct answer from group B for the statements given in the group A. In group A, question A, the weight per unit volume of a liquid is specific weight or weight density. In group B, it will be option capital C. Next question B, in group A, the unit of surface tension is Newton per meter. Option capital A in group B. Question C, in group A, the unit of pressure is Newton per meter square. Option capital D in group B. Question D, the pressure intensity at any point in a liquid is W into H. Option capital B in group B, where W is the specific weight of the liquid and H is the depth of the liquid from the surface. Question number 74. The stability of a dam is checked for tension at the base, overturning of the wall or dam, sliding of the wall or dam. Option D is right answer all of these. Question number 75. When a body is placed over a liquid, it is subjected to gravitational force and upthrust of the liquid. Option A is right answer, true. Question number 76. When a body is placed over a liquid, it will sink down if gravitational force is more than upthrust of the liquid. Option C is right answer. Question number 77. When a body is placed over a liquid, it will float if the gravitational force is less than the upthrust of the liquid. Option B is right answer. Question number 78. When a body is immersed wholly or partially in a liquid, it is lifted up by a force equal to the weight of the liquid displaced by the body. This statement is called Archimedes principle. Option B is right answer. Question number 79. The tendency of a liquid to uplift a submerged body because of the upward thrust of the liquid is known as buoyancy. Option A is right answer, agree. Question number 80. The force of buoyancy is always equal to the weight of the full liquid displaced by the body. Option A is right answer. Question number 81. The body will float if the force of buoyancy is more than the weight of the liquid displaced. Option C is right answer. Question number 82. The body will sink down if the force of buoyancy is less than the weight of the liquid displaced. Question number 83. The center of gravity of the volume of the liquid displaced is center of buoyancy. Option B is right answer. Question number 84. The center of buoyancy is the center of area of the immersed body. No. Option B is right answer. Question number 85. Question number 85. The buoyancy depends upon the weight of the liquid, density of the liquid, and volume of the body. So option A is right answer. Question number 86. A uniform body of 3 meter long, 2 meter wide and 1 meter deep floats in water. If the depth of immersion is 0.6 meter, then the weight of the body is. The weight of the body will be equal to buoyant force, and that will be equal to rho into G into V. Rho is the density of water, G is the acceleration due to gravity, and V is the volume of immersion of the body. So volume of immersion of the body will be 3 into 2 into 0.6, because the depth of immersion is 0.6, so 3.6 meter square. So if we put the value into the equation of buoyant force, that will be equal to weight of the body equal to 1 into 9.81 into 3.6. We will get the weight of the body equal to 35.3 kilonewton. Option C is right answer. Question number 87. When a body floating in a liquid is given a small angular displacement, it starts oscillating about a point which is known as metacenter. Option D is right answer. Question number 88. The metacentric height is the distance between the center of gravity of the floating body and the metacenter. Option B is right answer. Question number 89. The line of action of the force of buoyancy acts through the center of gravity of the volume of the liquid displaced. Option A is right answer, true. Question number 90. The metacentric heights of two floating bodies A and B are 1 meter and 1.5 meter respectively. Select the correct statement. Option C is right answer, that the body B is more stable than body A because it has more metacentric height. Question number 91. If a body floating in a liquid returns back to its original position when given a small angular displacement, the body is said to be in stable equilibrium. Option B is right answer. Equilibrium of floating bodies. The equilibrium of floating bodies is of the following three types. Stable equilibrium. If a body floating in a liquid returns back to its original position when given a small angular displacement, then the body is said to be in stable equilibrium. Next, unstable equilibrium. If a body floating in a liquid does not return back to its original position and heels further away when given a small angular displacement, then the body is said to be in unstable equilibrium. Next, neutral equilibrium. If a body is floating in a liquid, occupies a new position and remains at rest in this new position when given a small angular displacement, then the body is said to be in neutral equilibrium. So option B is right answer for question number 91. Question number 92. If a body floating in a liquid does not return back to its original position and heels further away when given a small angular displacement, then the body is said to be in neutral equilibrium. No, then the body is said to be in unstable equilibrium. Option B is right answer for this question. Question number 93. If a body floating in a liquid occupies a new position and remains at rest in this new position when given a small angular displacement, the body is said to be in neutral equilibrium. Option A is right answer. Question number 94. A body floating in a liquid is said to be in neutral equilibrium if its metacenter coincides with its center of gravity. Option A is right answer. And the body will be in stable equilibrium if the metacenter is above the center of gravity, and the floating body will be in unstable equilibrium if the metacenter is below the center of gravity of the body. Question number 95. A body floating in a liquid is said to be in stable equilibrium if the metacenter coincides with its center of gravity. No, if the metacenter is above the center of gravity. Question number 96. A body floating in a liquid is said to be not in equilibrium if its metacenter lies below the center of gravity. Option A is right answer. Agree. Question number 97. A submerged body is said to be in stable equilibrium if its center of gravity lies below the center of buoyancy. Option B is right answer. Question number 98. The time of oscillation T of a floating body is given by 2 pi k square 2 pi into root over of k square by h into g, where k is the radius of gyration of the floating body about its center of gravity and h is the metacentric height of the floating body. Option A is right answer. Question number 99. The metacentric height of a ship is 0.6 meter and the radius of gyration is 4 meter. The time of rolling of a ship is. We know the formula for time of oscillation T equal to 2 pi into root over of k square by h into g. So we got the value of k, which is equal to radius of gyration equal to 4 meter and height of ship equal to 0.6 meter, and h is the acceleration due to gravity, which is equal to 9.81 meter square per second. So if we put the value into the equation and calculate, we will get t equal to 10.4 second. Option C is right answer. Question number 100. The quantity of a liquid flowing per second through a section of pipe or channel is called discharge and is measured in cubic or meter cube per second. Option A is right answer. True.